And here you go. Raise your hand if you are for sure, if you know for sure. Obviously, you have time to change your schedule. Some people could add, some people would drop. Raise your hand if you know for sure you're taking second semester with me. Okay? So at least got 5 of you or so. Um, yes, if you're a junior, you're taking second semester. There's no question. So, we will teach you how to graph. Second semester, you're going to learn how to graph that. In fact, you'll learn how to graph it quickly. And you'll learn how to graph it well. Okay, Zelly says that's easy stuff. Actually, just put it in your calculator. No, you're going to graph it by hand with no calculator. Trust me. We'll get you to do it really well. Actually makes a wave. Now, we'll teach you how to do that. It'll be good stuff. But in order to teach you how to do that, you need to understand today's lesson. Today's lesson is pretty straightforward. It's really good stuff. And we start with talking about parent functions. These are the most important functions that we use. And we're going to transform them. We're going to move them around. We start with an example like y is equal to 4. So f of x equal to some constant. That's one type of function that we start to graph. We're going to start by graphing y is equal to 4. So what I do is I choose certain x values. I'm going to choose -2, -1, 0, 1, and 2. Given those x values, I'm going to produce y values. Notice there's nowhere to plug in an x. However, it says that y is always 4. So if x is 2, -2, what would y be? What is y always? 4. Suppose x was -1. What would y be? 4. Hey, I'm going to change it up. Suppose x was 0. What would y be? We're going to do something different now. Suppose x was 1. What would y be? I don't see anybody smiling yet. Okay, so as I plot these, I've got back 2 and up 4. Back 1 and up 4. All lines are straight. 0 and up 4. It's not a line anymore. Isn't that the definition of a line? Oh, no, that's a curve. So if you have y is equal to a constant, it's simply a horizontal line. This one happens to pass through 4. Here's another function. F of x equals x, or y is equal to x. It's an example. JJ, what would you like y to be equal to? Y is equal to 7. Now that you know what y equals 4 looks like, my guess is you now know that y equals 7 looks like that. Now what would you like y to be equal to? Y equals 2? Yeah. I just picked one for an example. We could have picked any of these up there. Yep. All right, the next one, y is equal to x. Okay? I'm going to choose -2. I'm going to pick in some points. I'm going to pick some points to plug in. If x is -2, what would y be? If x is -1, what would y be? As you plot these points, how is it similar to the first one? It's a line. How is it different? It's got a slant to it. Yep, it has slope. Y equals x is a parent function for linear functions. Soup, what shape does the next one make? Very good, JJ. It makes a parabola. Let's see why. I plug in. So I'm going to graph y equals x squared. These are the same things. F of x equals x squared, y equals x squared. You can interchange the y and the f of x. Okay. If I take -2 and I plug it in, what do you get? 4. If you square a negative, it becomes positive. Square -1, you get 1. Square of 0, you get? We have 1 and 4. I plot these points. JGL is correct. You do get a parabola shape. Parabola. Does anybody know what the next one looks like? Squiggly stuff. So it looks like this. Okay. That would be incorrect. But thank you for your offer. We are going to plug in, so we have y equals x cubed. We'll try again -2, -1, 0, 1, and 2. If I take -2 and cube it, what do I get? -8. -1 times -1 times -1. We all speak gibberish. 0 times 0 times 0. 1 times 1 times 1. And 2 times 2 times 2. Suppose there were enough lines on the graph. My guess is it would be somewhere down here. Figuratively speaking, are you being literal about using the word literally? X cubed makes that shape. JGL described it as the squiggly thing. Okay. Well, it's called a cubic. Quadratic, cubic. Next one is the square root function. Square root it. So I'm going to start by plugging in. I'm going to plug in -4. What's the square root of -4? No, 2 times 2 is 4. Square root of -4. -2 times -2 is +4. Square root of -4. Can't do it. Can't take square root of negative. You don't plug in negatives for a square root. We start by plugging in 0, then we'll do 1, then we'll do 4, we'll do 9er. Why did I choose 0, 1, 4, and 9? Because they're perfect squares. Square root of 0 is 0. Square root of 1, square root of 4, square root of 9 is 3. Yep, kind of a short curve. Notice how it starts at 0, 0. It does not go over to the left. It only moves over to the right because you can't have the square root of negative numbers. We actually, for those of you who maybe have talked about this before, we call that the domain of the function. The domain is only non-negative numbers. Do you yep, Soup has this one. The square or the absolute value of x, it does make a V shape. This is our last one. And by the way, these 6, you need to commit these 6 to memory. Okay, you need to know what these 6 shapes are. The absolute value of -2 is 2. Absolute value of -1 is 1. We have 0, 1, and 2. And here you have it. So those are the 6 parent functions you want to keep in mind. We're now going to talk about what happens when you move them around. So move over to this side. And YouTube Nation, I'm going to pause this. Okay, Jack, don't worry about it. You're going to be okay. So I take the first function. So as I'm looking at this screen right here, where is all my stuff? Oh, here we are. Y is equal to x squared. I want to see what happens to it if I graph y equals x squared plus 4. Anybody want to make a prediction what's going to happen if I add 4? Well, let's check it out. So I'm going to go with Desmos. I go y is equal to x squared and then I add 4 to it, and you get that blue shape. Very good. JGL, right where it says y equals x squared plus 4, just right underneath there, up 4. Grab your marker. Up 4. Up 4. We're giving you time to practice here. Good job. Okay, we're giving an arrow up 4. Great. Anybody want to guess what happens with the next one? I'm getting an upside down prediction here. Let's see what happens. I have y is equal to negative x squared plus 4. And I get the green. You're absolutely right. It's upside down and it's up 4. JJ. Right? Write it down. Yeah. Upside down, up 4. Very good. Upside down and up 4 for that one. Anybody want to guess what the next one does? I'm getting a wide guess. Anybody else? Super thin? Let's check it out. We have y is equal to parentheses x minus 3 parentheses and I squared. What did it do? What did it do? It moved it right 3. JJ, get up there. Right 3. What about the next one? A guess there? I got a left 2 for a guess. No. Don't write it yet. All right, let's check it out. We've got y is equal to parentheses x plus 2 parentheses squared. I get the black one. Yes, that is left 2. Great guess. Go ahead, write left 2 there, JJ. And the last one, I have 3 transformations. I got the negative, I got the x plus 5 squared, I got the plus 1. It's time for you to put it all together, knowing what we've learned now, what's going to happen with that shape. Good. Upside down, left 5, and up 1. Let's see if that happens. I've got y equals negative parentheses x plus 5 parentheses squared plus 1. There it is. JJ, write it all down. Upside down, left 5, up 1. Left 5, and up 1. You do not get to use decimals on your test, but you could use it to check your homework for today and up until the test time. So let's summarize and try the problem so you can see exactly what's happening. What happens when you get a negative on the outside? Flips upside down. What happens when we get an H on the inside? Moves left to right. And did you notice how it was opposite of what you thought? If it was a plus 2, it moved left 2. If it was minus 2, it moved right 2. And then what did this thing do on the outside here? Up and down. So all we want to be able to do is just identify what the parent function looks like and then use the transformation. So this is x to the first power. So the parent function is y is equal to x, which looks like that. Only in this situation, I have x minus 3. So what's that going to do to the shape? Moves it down 3. So after I graph that, I then draw one where it's move down 3 units. And that's it. The next one is being squared. So my parent function is y equals x squared. We just talked about that shape. It's a parabola. Who can tell me what is the plus 4 going to do? Move it to the left 4 units. The next one, the parent function is y is equal to absolute value of x. Somebody describe that shape for me. It's a V. So what's the minus 3 going to do? Move it down 3 units. The next one has a square root. So the parent function is y is equal to the square root of x. We know what that looks like. Looks like that. What is the transformation here? There's 2 of them. Right 1, up 3. Right 1, up 3. There's my new shape. Probably should have done a better job of giving that a little bit of a curve. Next one, we've got y equals x cubed. What does that look like? Little squiggle. So what's the transformation here? What's going to happen to it? Left 2, down 3. Back 2, down 3. And then the next one, again, we have y is equal to x squared. What are the transformations that will happen for this one? Upside down, right 5, up 2. There you have it. So can we just pause and admit that if we looked at this at the very beginning, that we would not have a whole lot of an idea of how to graph that? And yet now we made it super quick. So that's the idea, okay? All right, I'll get you your assignment.